What do you mean?
Like you gave us like 5 problems out of the entire.
Oh, yeah, all of them.
Now do the rest.
Yeah. Okay, so let's continue here. All right, so let's review one more time, right? Implicit differentiation. You have to take a derivative of both sides with respect to x. That's what makes it implicit differentiation. Collect the terms with dy dx on one side, factor out a dy dx, and then solve for dy dx. Okay? All right, so let's do this one. This is a different type of problem because look, I've got x squared, I've got y squared. So far, it's like the ones we've been solving equals to a constant, but there is this other term here, minus xy. This is what makes it an implicit function because you cannot solve this just for y, right? So let's take a derivative of this. Okay. Here's what we're going to do. We're going to do d dx of this and d dx of this. Okay? I'm going to take another step and just write it more like specifically, right, with like a d dx on each of them. So for example, I need to take a derivative of this minus a derivative of this plus a derivative of this equals the derivative of that. Okay? Okay, so first term, derivative of x squared is what? 2x. Okay, what's the derivative of this here, y squared? 2y dy dx. Okay, there is a situation here. It's x times y. This is product rule. Okay, so here's what we got to do. U is x, v is y. U prime is 1, v prime is dy dx. Okay, it's the derivative. Because it's d dx with respect to x, right? It's the derivative with respect to x. So now, this is going to be 2x minus, here, the derivative of that in parentheses. So it's going to be x dy dx plus y. Okay? Does that make sense?
Yeah.
Okay, now you continue plus 2y dy dx equal to what? 0. Okay, so you see what happened? Derivative, and because it's xy multiplied by each other, that's got to be a product rule. Okay, so now distribute. So 2x minus x dy dx minus y plus 2y dy dx equals 0. Okay, now what are we going to do? Collect all of the dy dx's on one side and bring everything else to the other side. So I have negative x dy dx plus 2y dy dx. Whatever didn't have a dy dx, so like the 2x and the negative y, is going to go on the other side. Negative 2x plus y. Okay? Now, factor out a dy dx, and I get negative x plus 2y equal to negative 2x plus y. Now what? Divide by the parentheses, so dy dx is negative 2x plus y over negative x plus 2y. Okay, and that's it, you're done, because you solved for dy dx, that's what you wanted, and we're not done with the problem, but we're done with the derivative. Okay, now, if you check in the back of the book for ones like this, they'll probably write it in like reverse form, like they'll swap the places for these, because convention, mathematicians, like we never want, like math people never want a negative on the outside, like we always, I don't know why, it's like a thing. So like it'll be written like this. Isn't it much cleaner this way? It's like a, you know, you don't want like a, you know, you don't want like a straight negative. right? Anywhere? So just like incorporate, okay? So either of these are the same. There's nothing different between these two, okay? But the book will probably have it that way. Okay, are we done with this problem?
No, you have to plug
Now
in
you
the
have
negative
to,
one.
right. So now we have to evaluate dy dx at the point -1, comma 2. Okay? Now we're going to plug it in, right? Because this is x, this is y. So y is 2 minus 2 times -1, 2 times 2 minus -1. This is where people make a mistake. Like they do everything correctly, and then when it comes like down to like all these negatives and the ones and the twos, people just, you know, I don't know. We kind of let our brain kind of like take a break for a little bit, and then there's like little computation errors, which sucks because, okay. Are we done now? Or have we answered the question?
Yeah.
Have we?
Normal line.
Find the tangent and the normal to the ellipse. So this isn't even anything. This is just the slope of the tangent line. So the tangent line is y minus, what's y1? What do I put for y? 2 equal to 4/5 x plus 1. And then normal, y minus 2 equals -5/4 x plus 1. Remember when that was like the biggest thing? It was like tangent and normal. Remember? Perpendicular. I know.
That was
See?
like really hard for me.
I'm telling you guys. Okay.
So that's the answer though.
That's the answer now. Right? That's super. We're going to use implicit differentiation to find dy dx and then the second derivative as well.
Would there ever be a question to like find the normal tangent and then dy dx? Like would that all be in the same problem ever? Like d2y, d2x?
I mean, maybe. But once you find one derivative, you can find the other derivative. Yeah.
So for the first step, we're always gonna
Okay, so we're going to do d dx of this one. And then d dx of this one. Okay? So first. Okay. First one, it's what? 2y dy dx plus 2 dy dx equals to what? Just 2? You guys agree? Yes. Okay, now we can divide everything by 2. Get rid of that 2. So I got y dy dx plus 1 dy dx equals 1. Everybody okay with this?
So you're into the step where you split it up.
Not yet. What do you mean? Oh, the product rule? There was no need for the product rule because I didn't have an x and a y multiplied by each other. Okay? I just divided by 2's. So I did calculus, took the derivative, then in the blue I just divided 2's, no calculus there. Now calculus is kind of gonna stop for a minute. It's just gonna be algebra. We're gonna factor out a dy dx. So when I factor out a dy dx, what do I have left? Y plus 1. And now, so divide by that, so dy dx is 1 over y plus 1. Okay, that's fine, but that's not what we want. Okay, that was dy dx, so that's fine. That's the first part. Now I want to find the derivative of this. Okay, so let's start with that. Dy dx, not quite. Okay, so we want to take the second derivative, which means it's going to be d dx of this. Okay, and now that we've been using this more and more, do you see how it's d dx of d dx? So it's 2 d's. That's why it's d squared y and then dx squared. Okay? D squared y dx squared. Because dx is not two things. It's one thing, dx. Okay, so d squared y. Oh, you know what? Okay, before I go there. So how are we going to take a derivative of this? Quotient rule is no good. I mean, you can do quotient rule, but whenever you can avoid it, avoid it. Right. Put it in the top. So this is going to be, it's d dx of y plus 1 to the negative 1. This says d squared y dx squared. This.
Because you have.
So we're going to take a second derivative, right? So all this together is d squared y dx squared. Remember how we're going to... Huh? You can, but none of the cool people do. Okay?
If you want to be a loser.
Okay, so how are we going to take a derivative of this?
Yeah,
Chain rule. So negative y plus 1 to the negative 2 times what's the derivative of the inside?
Oh, y dy dx. 1 dy dx. Just dy dx.
dy, okay.
There we go.
The derivative of the inside is the derivative of this, which is dy dx plus 0. So dy dx. Okay. Yes. Okay, so first the negative comes down, times this to the power of negative 2. Now, we want to take a derivative of the inside. Derivative of this is dy dx plus 0.
But what happened to the original ddx? Wouldn't
So
it be negative?
ddx of this was telling us take a derivative. Now we took a derivative. Wait, any other questions?
And then you multiply by dy dxy.
Okay, so now here's what we're going to do. This has a negative exponent, so it's got to come down, right? So this is going to be negative 1 over y plus 1 squared times dy dx.
Oh, dy dx stays.
No, dy dx doesn't stay. What is dy dx? We found it here. So we got to bring it there. Yep.
That's crazy.
Yep.
I would know.
So I know you wouldn't know how to do it. This is why we're learning it now, right? There is no way for anybody to know, but like we can't have it in terms of dy dx. So now this is going to be negative 1 over y plus 1 squared times, what's dy dx? 1 over y plus 1.
We just leave that.
Nope. Because multiply two fractions, you multiply the numerators, and you multiply the denominators, so you got y plus 1 cubed, and now we're done. Okay? Because this squared times this is cubed.
Oh, you multiply it?
Right. So, we took a derivative, nothing new. I mean, nothing, everything was like what we were learning in this lesson. Now you have to take another derivative. But when you take another derivative, this time you've got x's, you've got y's, but you've also got dy dx, which you can't have in your final answer. So for these, you always have to substitute
Oh, you put
the
it
dy
in
dx. You take this and you put it back, right? Which it's never going to be extra work because you can never take the second derivative without finding the first derivative. So like it's like you just use what you found on your way, okay?
So much stuff can go
All right,
wrong here.
so much.
You never know when you're done.
You never know when you're done. But like, why do we need to find the second derivative? Because we learned now that when you have position, the first derivative is velocity and the second derivative is acceleration. So you have, like, you can't get away with not finding second derivative. And your functions are not always going to be the simple functions for position, let's say, like you had before, right? Like sometimes they're going to be a little bit more complicated. So, okay. But then like third and fourth derivatives, those don't have as many like practical implications, so we don't really like do all that. But let's never forget that the only, like the reason why Newton invented calculus was because he wanted a way in order to express all of the laws of physics, right? And so like these came out of a practical need, right? And so, right? So there is a practical need for them. Okay, let's do some more because we can never have enough of these. Of the order, you know, the chain rule and product rule and stuff. Okay. Yep.
Is this our last chapter?
There's gonna be a little bit more and then a quiz, like 3 more lessons and a quiz. Yeah.
No more tests?
No test, just a quiz after this test. It's test and then a quiz. And then the final. Yep. Okay. So powers again. Find dy dx. Okay, so dy dx. Okay, some of you guys, most of you are okay with this. when this negative comes, the negative half comes down, it turns into a coefficient. So now it multiplies to all of the other coefficients that were already there. So it's negative half times 4x to the negative what? 3 over 2. So dy dx is negative 2, okay? But this x to the negative 3 over 2, where does it go? Bottom, and it becomes x to the 3 over 2. Okay, that's an acceptable answer. This is also an acceptable answer. And then so is, negative. And so is this, negative 2 over the square root of x cubed on the outside. All of these are okay. And the reason why I want you to know that all of these are the same, I'm not going to ask you for one versus the other, but sometimes the book has it in one form versus the other. And then next year, if you take calculus again and there is a multiple choice situation, you never know what form the multiple choice will be in. Because it was negative half times 4. That became negative 2. Because it has a negative exponent, x to the power of negative. Correct, because you have to always ask yourself, who does this exponent belong to? Just the x. So whoever the exponent belongs to, that's what goes on the bottom. Okay?
Also multiply by 4, like 1/2 times 4.
That's one half times what?
Like, aren't you supposed to like multiply by 4 after the 4?
No, we did it here. 1/2 times 4, that became 2, negative 2. Yeah.
Do you want us to write the 2 outside of
This 2? Or,
no, on the,
oh, this one?
because isn't the bottom one supposed to go outside and then the,
Yeah, but if it's a 2, it's just the square root, so you can omit it.
oh.
You don't write it, but it was like a 3 or a 4 or a 5, then you have to. Yeah. Okay. Yep.
That's fine.
Okay. So what's going to happen here?
So they'll want to rewrite it.
And then
Well, how would you
product rule. So x. Okay. Okay, so let's see. U is x. And then v is this thing. I was actually going to have you guys do this alone, but there is some factoring. Let's do it together. No, you only move down if there is a negative exponent.
No, I mean like, take the coefficient.
Oh, yeah. I haven't started taking a derivative yet. I'm going to do it right now. Because first we got to set up the product rule. Okay, so u prime is 1. V prime, okay, tell me what's v prime.
1/2 x cubed plus 1 negative x.
Okay, times 3x squared. Okay, derivative of the inside. Okay, now, do you guys mind? Let's clean that up a little bit. So let's bring the 3x squared to the front. So let's write it like this. 3x squared over 2. X cubed plus 1 to the negative half.
Wait.
I brought this.
Oh, yeah.
Okay, now, okay, let's do product rule. So when you're, okay, now that we're all getting better at taking the derivatives, the next thing we're going to work on is form, proper labeling, and putting in equal signs in between the steps, right? Like sophisticated math students, right? So dy dx and then equals. Okay, should I zoom in?
Yeah, because it's times the 1/2.
There's so much to write. I'm like trying to write small, but okay. So u times v prime, right? So like it's going to be this x times this. So what's the x going to combine with and create what? 3x cubed over squared. I mean over 2, sorry. 3x cubed over 2 times this. Everybody okay with that? This is uv prime.
Don't write the dy dx, so you're going to take off points.
No. But then if you have to use dy dx in another answer, like we did before, you have to have like those bookkeeping skills, right? Okay, plus what now? This one. Okay. Okay. Do you guys notice a factoring situation here?
Yes.
Yes. Yeah? Okay. So this is going to be, okay, what are we going to factor out?
X cubed plus 1 to the negative.
Okay, let me write it a little bit further down here. X, huh?
Is it negative a half for both?
No, just one.
Oh.
So one, okay, these two terms are the same. They have different exponents. We factor out the one with the smallest value exponent, and that's the negative 1/2. Okay, now, okay, so let's see what we're going to have left inside. When you factor out, it's like mentally you're dividing each term by the thing you're factoring out. Okay? In the beginning, go ahead and write it so you know. Like when I write it, now I see, okay, this isn't going anywhere. It's going to stay. So that's 3x cubed over 2. Okay, then this stuff here, you see how it's like identical? It's the same, this to the negative half, this to the negative half. That goes away. So you just have like 1. It cancels out. Okay, plus, now I have, yeah.
It just wouldn't be 3x squared.
No, because I multiplied that by this before. Now I have same thing, same base, different exponents. We're dividing. What do we do with the exponents? Subtract the exponents. And look, in the beginning, write it down. 1/2 minus, so I write 1/2 minus, top minus, then my eyes go to the next one, and that's negative half. Because if your eyes are trying to see the whole thing at the same time, the negatives always get lost in the way. Okay, so now what do I have? This is going to be a fraction, right? 1 over x cubed plus 1 to the half. Okay, what's this going to be? 3x cubed over 2 plus what? Yeah. X cubed plus 1. Okay? But that's no good.
That's no good.
That's no good because we need to combine these. Okay, so let's see how we can combine these. This is going to be 1 over x cubed plus 1 to the half times, in the parentheses, I want to make that a common denominator. So I have to multiply all of these by 2 over 2. Sorry, I had to write small on that one. Do you guys see this? Okay, you see how this is a 2? We have to make all these a common denominator. So multiply 2 over 2, 2 over 2. So now what do I have? 3x cubed plus 2x cubed plus 1.
I'm sorry, I don't
It would be
understand.
plus 1.
Okay. Huh? With a what from the where?
How do I know how to do that? Like, I just don't know.
Okay, so here's how you know. You know what? Let me just write all this bigger here, okay? This is what we had. Okay. Plus x cubed plus 1. Okay. Is everybody, I rewrote this here. Okay? Okay. Let's go from here. Let's backtrack one more. This just got rewritten. 3x cubed over 2. This one was just x cubed plus 1. Okay. Now, we need to combine this, right? Because you've got 1, 2, 3 terms. You just have to combine them because you've got x cubes, these combine. How do we combine them? Now we're adding fractions. If this has a denominator of 2, I need to make those a common denominator of 2. And there are lots of ways to do this. How would you guys make that a common denominator of 2? Multiply, so whatever this is, multiply each of the other ones by 2 over 2. Okay? Yes, same denominator. So now, I have 1 over x cubed plus 1 to the half times, okay, so look at what I have here. 3x cubed plus 2x cubed, 5x cubed plus 2 over 2. But we multiplied that by 2 as well. So let's, okay, all of these denominators are going to be a 2. Okay? What do you have in the numerators? 3x cubed plus 2x cubed plus 2. So that's 5x cubed plus 2.
Two's cancel.
Can we leave this?
No, 2's can't cancel out. Huh? No, like to get rid of the total denominator? You can't because it's not an equation. You have to do that to an equation, then you're changing the problem. No, because then you would have found dy dx divided by 2. Or you would have found like 2 dy dx. No, it won't. Okay?
2 over 2.1? No.
Yeah, exactly.
Yeah, that's what I don't understand.
No, it was 1. Okay, let's do this. If you have x cubed over 2 plus 1, how do you make it a common denominator?
Multiply by 2 over 2.
You multiply this by 2 over 2, right? So now what do you have? You have the denominator is now 2
2x cubed.
x cubed plus 2. Okay, that's the answer. So these, right, I've included them every now and then because these were technically we learned these skills lessons ago, but it's just so much, right? It's so much, and we always need more. So new stuff, review. So, okay, so let's add in, okay, let's do this one. Something to the exponent. So what happens to the exponent for dy dx? Exponent comes down. This comes down and multiplies with that 3. So I have -1, 2x to the negative half, plus 1 to the power of what?
What's negative 1 over 3rd minus 1?
Negative a third minus 1.
Which is what?
Four-thirds.
Negative a third minus 1. This is negative a third minus 3 over 3, negative 4 over 3. Okay? Times, let's do the derivative of the inside. I'm going to do that in this color. Okay. The half comes down, so we got negative x to the negative what?
3 over 2.
3 over 2 plus 0, right?
It can't equal k.
Okay.
You can't just bring it to the bottom.
So, well, we can, but take a look here. We've got a negative here and a negative here. Those cancel each other out.
Wait, what?
Okay?
Oh, the negative 1? Yeah, that's so true.
Okay, so now dy dx is, okay, lots of negative exponents here, right? We're just going to deal with them one at a time. First of all, you have this negative 4 over 3. Who does that belong to?
2x.
2x to negative half plus 1.
The parentheses, right? So the entire parentheses comes down.
And you do negative.
So it's 1 over 2x to the negative half plus 1 to the 4/3.
Can you leave the negative in that though?
No, hang on. Times, what about this blue one?
That also
Who does that negative 3 over 2 belong to?
X.
The x, where does that go?
1 over x.
Okay,
becomes another.
Isn't it still? Is it still negative?
it's still negative. Now we got to go there, okay?
Wait, no, the negative 3 over 2.
No, we brought it down and it became positive. This negative 3 over 2?
Yeah, I just thought that the reason we did that is because of the negative x. But you can do that for both.
No, the negative x.
No, the negative x cancel. This negative and this negative
Oh.
cancel.
Okay.
Okay, so now this is going to be 1 over 2 over x to the half plus 1 to the 4/3 times 1 over x to the 3 over 2. I know.
It's just like
This is gonna be
It does look illegal.
It was illegal. This was illegal. Here. That was illegal. Right there. Now it's all legal. Now this is all legal stuff. This is good. Look, it's cool stuff. I'm not even, okay? This is the whole, this is that. Yep.
I would totally try to multiply.
No, you can't
don't know what
multiply
to
because
solve.
you've got an exponent of 4/3. You can't distribute that inside.
It's hard though because I feel like sometimes.
I know. It's a complex fraction. We call it a complex fraction. It's like a double. Huh? Oh, yeah. 2 over root x, of course. Okay. This is another one of those factoring problems. Okay?
I just have a quick question about,
Yeah.
about problem C. So
Yeah.
you can't multiply the denominators because they just have different.
Well, you have to for C, you gotta bring it to the top. Oh, there's 2 C's.
Yep.
Because they have different exponents. That's why that.
Because the parentheses have an exponent, and that's like a gatekeeper. It doesn't let anything else come in.
Oh.
Yep. Okay. All right. Product rule. Because this one we can't. Well, actually, no. We don't have to do product. Yes.
We
Sorry.
don't do close.
I misspoke entirely. First, I thought I was saying quotient rule, but this is product rule.
You bring it to
Because we're going to rewrite this as
x squared plus 1.
x squared plus 1 to the half. So u is x, u prime is 1. Yeah, negative. Now that class is, thank you. Now that class is almost over, I get antsy because I think I'm not going to finish. Okay, v. I know. Okay, v prime. Negative half x squared plus 1 negative 3 over 2 times the derivative of the inside 2x. V prime now is
Negative.
this and this cancel. So it's negative x squared plus 1 negative 3 over 2.
And then you can
Okay,
bring that to
okay, hang on. Shh. No, hang on. Okay. Shh. Okay, guys, no interruptions because I gotta finish this. Okay. Let's take a derivative. Okay, dy dx. For this, yes. Not for the implicit differentiation before. Okay. Multiply this times that. X times negative x is negative x squared plus 1 to the negative 3 over 2 plus x squared plus 1 to the negative half. Okay, do you see how there's a factoring situation again? We're going to factor out x squared plus 1 to the negative 3 over 2 because that's the lower valued number. Okay, from this first bit, what do I have left? Negative x squared. Plus, here, okay, it's like we were dividing by this. So this is the base, same base, different exponents. We subtract the exponents. So it's minus minus, which is plus. So let's see what we have left. Okay, this is going to come down now. Okay?
Wait, you're negative 1/2.
No, it's minus minus. X squared plus 1 to the 3 over 2. Okay, so let's see what we got here. X squared plus, no, negative, hang on, sorry. Negative x squared plus x squared plus 1 to the power of what? Minus half plus 3 over 2 is what? 1. Minus a half plus 3 over 2 is 1. So it's just x squared plus 1 to the power of 1, so I don't even need a parenthesis there. So now look at what happens here. What happens inside the parentheses?
X squares cancel.
The x squares go away. Negative x squared plus x squared, 0 plus 1. 1 times this. So the answer is just 1 over x squared plus 1 to the 3 over 2. Okay?